Let's look at the area of a sector. A sector is a pie-shaped part of a circle made of an arc along with its two radii. Sector is part of the area of a circle. So think about it as either a piece of pie or a piece of pizza. The shaded area is known as the sector. Because it is a portion of the area, we will set up a proportion between the area of the sector, which we're going to use S, over A, which would be the area of the entire circle, equals M, which is the degree measure of the arc or arcs if you're finding multiple sectors, over 360. And again, it's because the arc is part of 360 and the area of the sector is part of the area of the entire circle. And you can set it up the other way. So I have M over 360 equals S over A. You can do S over A equals M over 360. Either way is completely fine. And there are some different ways that you can also write it if you're looking up on other websites. All right, so example 1, we are trying to find the area of the shaded region. We're going to round to the 10th place. So I'm going to use my formula. S over A equals M over 360, and we're going to plug in the values that we know. We do not know S. A represents the area of the circle, which can be found by using the formula pi r squared. So area equals pi r squared. We need to look at what's given. They tell us PQ is 22 and PQ is the radius. So we are going to do pi times 22 squared. 22 squared is 484, so that makes the area 484 pi. Don't forget about the pi. I'm going to leave it in exact form until the very end. The other thing we need to fill in is the M, which is the degree measure of the arc. That would be the degree measure of the shaded sector, right? So the sector has arc PR. Because PQR is a central angle, then we know that the degree measure of arc PR is 139 degrees. So our setup is going to be S over 484 pi equals 139 over 360. And then once you get the setup, you will cross multiply. So we're going to do S times 360, which is 360S, equals, and depending on your calculator, if I'm using a TI-36X Pro, I'll probably type the whole thing in, but if I'm using something like Desmos, then I'm going to type 484 times 139, which is going to give me 67,276, and then I'm going to tack the pi on at the end. I'm going to save the rounding for the very last step. Now to get the S by itself, I'm going to divide both sides by 360. And so what I would type in my calculator, again, regardless if I'm using the TI-36X Pro or Desmos, 67,276 pi over 360, utilizing that fraction button. And when you do that, you should get approximately 587.1. They gave us our unit is centimeters, and because this is area, it is going to be squared. So centimeters squared would be our final answer. For example 2, again, finding the area of the shaded region. Make sure you're looking at the shaded region and not the white, the unshaded region. So we are talking about all of this right here. Okay. So in order to find that, we need to know the area of the entire circle, since the area of the sector is part of the entire circle. And then we also need to know the degree measure of that big major arc L. Normally we would have a third point on there, but the major arc LN, not the minor arc LN. So I'm going to start by looking at what they gave us. They told us that MN is 29.5 miles. MN is the radius. So if we have the radius, we can find the area. So area is pi r is 29.5 squared. You can use a calculator and do 29.5 squared, which should be, it's going to be a pretty big number. Let's see, 870.25 pi. So I'm going to set up my proportion. So S over the area is 870.25 pi. We still need to find M over 360. So M is that degree measure of that major arc LN. So what I want you to notice is that we do have a right angle on angle M, which means that's 90 degrees. And if that is 90 degrees, then minor arc LN is 90 degrees. And so to find the major arc, you're going to do 360 minus 90, which would be 270. So now we are ready to cross multiply. So 360 times S, 360S equals, and again, when I use my calculator, I'm just going to do 270 times 870.25, and then I'll throw the pi on there. It is 234,967.5 pi. Then we divide by 360, and then we type that whole fraction into our calculator. And that should be approximately 2,040.5. Our unit they gave us was miles, but because this is area of a sector, we are going to square it. 2,040.5 miles squared. Next up, we are looking for the area of our shaded region, but this time we have two shaded regions. We do know that AC is a diameter and BC is a diameter. So because those are both diameters, that means a couple of different things. That means that the angles formed by those diameters are vertical angles and they're going to be congruent, which means that the degree measure of arc BC and the degree measure of arc AD will also be the same. So to find that degree measure, again, because AC is a diameter or because AD is a diameter, I'm just going to draw AC. Since AC is a diameter right here, that means we have a semicircle from ADC and we have a linear pair. So if we do 180 minus 143, that is going to give us the degree measure of, and this depends on how you look at it, either the angle or the arc. All right, so 180 minus 43 is 37. So both the central angle and the minor arc are 37, and that's true for the vertical angles and those corresponding arcs. We are also told that we have EB is 10.4. Make sure that you look carefully at EB. EB is a radius, so they are telling us the radius. Be careful because sometimes they might give you the diameter instead of the radius. So we're going to go ahead and find the area. So area is pi times radius, which is 10.4 squared. 10.4 squared is 108.16, and then we need the pi on there. So the area is going to be 108.16 pi. So now we're going to go ahead up and set up our proportion. So we don't know the area of the sector. We do know the area of the entire circle is 108.16 pi. To get the measure of the central angle, I'm going to or the arc degree measure, I'm going to combine those two arcs together. So 37 and 37, which is 74, and then over 360. The other thing you could do is just use 37 and then at the end double your answer since there are two sectors of the same size. But I'm just going to go ahead and do the total degree measure. So now we cross multiply. 360s equals 108.16 times 74 is 8,003.84 pi. Then we divide by 360. And then we go to our calculator, hit that fraction button, type it in exactly how you see it. You should get a nice approximation, which should be 69.8. The unit is millimeters, and because it's area, squared. All right, for our last problem, we are looking for, again, the area of the shaded region. This time we have 3 shaded regions. So we do need to know the area of the entire circle. So let's see what we've got. So they gave us PC is 12. If PC is 12, that means they gave us a radius of 12. So to find the area, pi times r, which is 12 squared. 12 squared is 144, so the area is 144 pi. So S over 144 pi equals, we need to figure out M. M is going to be these arc degrees combined. Okay, so there's a couple different ways to do it, but what I do is I notice these little marks on FE, CD, and AB. Those are your congruent marks. So that means that all 3 of those arcs are 62 degrees. So what I would do is I would take 360, which is the entire circle, and subtract out 3 times 62. Because it's the whole circle minus the 362 degree arcs. And that will give you 174. You don't have any diameter, so you can't use any linear pairs or anything like that, or vertical angles. So now that you have the setup, we're going to cross multiply. 360s equals 174 times 144 is 25,056. And make sure you have the pi. Divide both sides by 360. And then when we use our calculator, we will approximate that to 218.7 inches squared. So make sure you're using the correct formula. S over area equals the arc degree measure over 360. Make sure that when you find the area, you're using pi r squared, and make sure that when you're doing the degree measure, you do the total degree measure.